Hi, Jacob. In an effort to make some of the reading a little bit easier on these slides that it looks like you have a quiz for on Wednesday, um, excuse me, I wanted to go through and read through the slides for you. Um, it doesn't look like you necessarily have to read the actual chapter in the book as long as you look at what she has highlighted in these slides that she included. So I'll go through. I want to just make sure that I read through it for you so you have that, okay? So let's see. Lesson 1 on using appropriate speed. The objective for this is to describe the 3 major highway conditions that require you to adjust your speed. Excuse me. Okay, what is appropriate speed? A speed that keeps the driver traveling safely is obviously what's going to be appropriate, right? This means you must be aware of the conditions and drive accordingly. A reasonable, proper speed provides time and space to brake and steer to a safe alternate path 8 to 12 seconds ahead. Okay, so keeping that 8 to 12 seconds ahead in mind in order to brake safely when you need to. How to adjust to conditions. The first is visibility. Your speed affects the distance you can see ahead along your projected path. And she put an example in here. If you can only see 200 feet ahead of the vehicle because of inclement weather, which could be like fog or snow or whatever, you are driving 55 miles per hour, a speed that requires 300 feet to stop safely. So obviously, you know, if your visibility is not good, that you need to slow down in order to give yourself enough time to stop if you need. Traction. So rain, snow, sleet, or hail makes the road surface slippery and more difficult to drive, obviously making the traction not as good. Inclement weather conditions may require more time and distance to stop, so making sure that you slow down when you know that it's raining, snowing, or sleeting. And then the other one for adjusting to conditions is space. Make sure you have adequate distance to stop or maneuver safely. This may mean slowing down or changing lane positions. What she means by lane positions is 1, the center of the roadway, 2, left part of lane, or 3, right part of lane. And adjusting, you know, how you think would be the safest. When should you adjust speed? Most controlled actions take about 1/2 to 3/4 of a second to maneuver. High-risk maneuvers made under stress and with severe space constraints may take up to 10 seconds. When a safe distance can't be kept, drivers need to slow down. The closer to the object, the slower the speed. And then the last one in lesson review, there's some questions here. So if you take a look at these questions and you can answer them given the slides that she just did, then you're doing all right. If not, go back and look at those again if you need to, okay? So what are the 3 major highway conditions that require the driver to adjust speed? Well, those 3 major highway conditions: visibility, traction, space, okay? When should you adjust your speed? Well, think about conditions of the weather, whether there's something in the road, any of those things. And then what is the definition of appropriate speed? And let's see. What is appropriate speed? A speed that keeps the driver traveling safely. Okay, so those were those follow-up questions for lesson 1. Lesson 2, total stopping distance. The objectives for this are to describe the 3 components of total stopping distance and determine the total stopping distance for a vehicle traveling at 60 miles per hour. So what is total stopping distance? And here are the 3 components that you need to keep in mind. Human perception distance, so what you perceive or what you think the distance you have is, and I'm sure, yeah, it looks like she's going to describe all 3 of these. Human reaction distance and vehicle braking distance. So the first one Human perception distance. That's the distance your vehicle travels from the time your eyes see a hazard until your brain recognizes it. So your perception of, you know, there's a raccoon in the road up ahead, I now see it. It's that time between when your eyes recognize or you see it and you're making that, you know, quick decision on what to do. So at 60 miles per hour, you travel 44 to 66 feet in 1/2 second. So that looks like something that you probably need to keep in mind. At 60 miles per hour, you travel 44 to 66 feet in 1/2 second. Excuse me. Your human reaction distance is after you recognize that there's a problem, your body must physically react to it. So if you go back to the perception distance, that's the distance your vehicle travels from the time your eyes see the hazard. So you recognize that there's, I'm just using this as an example, that there is a raccoon ahead in the middle of the road. Now, your human reaction distance is after recognizing the problem, your body physically reacts to it. You make a physical reaction of what you're gonna do. So this is the distance your vehicle travels from the time your brain tells you to take your foot off the accelerator until your foot pushes the brake. That'll add an additional 44 to 66 feet, okay? So take a look back at this one. You're currently moving at 60 miles per hour, 44 to 66 feet in 1/2 second while you're just seeing that raccoon. Now you add an additional 44 to 66 feet as your body is reacting to what to do. And then this last slide, vehicle braking distance. This is the time that it takes the vehicle to begin slowing down once the brake is applied until the vehicle comes to a complete stop. So let's go back again. This is when you see that there's a problem. This is when your body decides to react. And now we're at the vehicle braking distance. So this is where you've hit the brakes now. And then the time or the distance, it says here, there's a number of factors that go into play with the distance that it takes for your vehicle as it's braking, from beginning to brake. All right, so here's that vehicle traveling at 60 miles per hour example she used. So for the average alert driver, so somebody who's paying close attention, not on their phone, not busy dancing and singing around in the vehicle, it will take a total of about 4 to 6 seconds to stop a 3,000-pound vehicle. This makes the total stopping distance approximately 248 to 292 feet. So all of those things considered, those 3 factors that we just read through, the vehicle traveling at 60 miles per hour, this is approximately how long it's gonna take to get that vehicle stopped because you've recognized that hazard. Okay, so she's got a little bit of a, I don't know, like a picture representation of what that would look like. Total stopping distance for 20 miles per hour, for 30 miles per hour, 40 miles per hour. So it gives you your perception distance. So when you see the hazard, you react to the hazard, you hit the brakes, then it equals your total stopping distance. So take a look at that picture representation because they're at different speeds. That one's 20, 30, 40. That one's really hard to see, but I'm gonna take a guess and say 50 since she's going up by tens. So that'll be important for you to kind of take a look at before you take your quiz. All right, so there's some lesson review questions for you. What 3 components make up that total stopping distance? Let's remember, I'll just go back to this one that'll show us. Perception, response, braking, okay? What are the total stopping distances when traveling 30, 50, and 60 miles per hour? Well, that's where this guy is gonna come in handy for you. Okay, so definitely take a look at that. All right, lesson 3. Natural laws and the movement of your vehicle. So the objectives for this lesson is that you're going to learn to describe the natural laws of inertia, friction, momentum, kinetic energy, and gravity, and then explain the relationship of those natural laws to driving. What are natural laws? Forces in nature that are always at work. Inertia. All physical objects have inertia. There are two aspects to this law. Moving objects continue to move in a straight line unless some force acts on them. So all things move in a straight line, of course, unless there's something that moves them in a different direction. Objects at rest do not move unless a force acts upon them. So, your vehicle is at rest unless, you're pushing it from behind, and then inertia. Example, she's got an example, like books on the back seat and you slam on the brakes. Well, they're not in movement, right? And then you slam on the brakes and the books begin to move, right? So that is what they mean by inertia. Friction, a force between two surfaces that resists the movement of one surface across the other. And her example here is helps your tires stick to the road. And you could use your sneakers as an example too. If they're not, if they're bald, you slide easily when you're running, walking, whatever. It's the same for your tires. If your tires are balding, then you don't have as much friction with the road, and you can easily slide. Friction between your tires and the roadway is called traction. Okay, so obviously, on a nice clear road, you have good traction. But let's say that road is ice covered or snow covered, and then the friction between your tires and the road is not working quite as well, then you lose traction, and that's why you slide. Momentum is the quality of motion in a moving object, a combination of weight and speed. All objects in motion have momentum. If the vehicle's speed or weight doubles, the momentum doubles. If the momentum that your car is moving at, if you're going at a higher speed, it's obviously at a higher momentum as well. And you see that, like, if you're going 60 miles per hour and you suddenly stop or you hit something, there's going to be far more damage or response because the momentum is higher, the speed is higher, as compared to, if your car is moving 15 or 20 miles per hour and you hit something, there's not nearly going to be as much momentum and you're not going to cause as much harm. Kinetic energy, the energy of motion, not the motion itself. So her example here is the faster a vehicle moves, the more energy of motion it has, right? Kinetic energy is it really just means anything in motion. And energy itself, if you are not in my biology class, you're not, so we're talking about kinetic and potential energy, but kinetic means that it's just being in motion. Gravity, the force that pulls all objects towards the center of the earth. That's why we don't float around, right? Center of gravity, evenly about a point somewhere in the center of the vehicle between all four tires. So she's just saying, obviously gravity is what keeps our vehicle on the road. Okay, lesson 3, review questions. What affects traction and how? So if you go back up, let's see, friction. So remember I said the better friction between your tires and the road, your sneakers and the ground, the better the traction. Okay, so friction and traction sort of have to go together. How would changes in a vehicle's center of gravity affect its stability? Well, look at the force that pulls the objects towards the center of the earth. So center of gravity for your car is evenly about a point somewhere in the center of the vehicle between all four tires. So if we go to this question, how would changes in the vehicle's center of gravity affect its stability? Well, let's say you have a flat tire and now you're only on 3 tires. That sort of cuts off changes your center of gravity. So that's how it would affect, obviously, the stability. Your car, you can't keep it straight if you're on 3 tires because your center of gravity or your stability is affected. What are the natural laws affecting drivers? Well, up here, natural laws are the forces of nature that are always at work. So the question was, what are the natural laws affecting drivers? Well, it's any of those things. It's your center of gravity. It's your kinetic energy, or how much emotion you are, or your momentum, how fast you're moving, your friction, or how well you're maintaining traction with the road. All of those are the different natural laws affecting you as a driver. All right, last lesson, lesson 4, natural laws and steering or braking. Lesson 4 objectives are: explain how natural laws affect a vehicle's stopping distance, identify the factors that affect steering, name the ways that natural laws affect steering around a curve, and then describe how gravity and the contour of the road affect steering. Okay, well, natural laws and braking distance. Factors affecting your braking distance, your speed, right? The greater the speed, the greater the momentum, the longer the braking distance. So if I'm going faster and I have to slam on my brakes really fast, obviously it's going to take a little bit longer for my car to come to a complete stop. Vehicle condition. Worn brakes, tires, or shocks obviously will reduce your traction in order to stop. So, if I'm having to brake really fast and I don't have great brakes in my vehicle, that is going to affect how quickly I'm able to brake. And then obviously roadway conditions as well. Roadway friction can be reduced due to weather and surface. So if it's snowy or icy out, that is going to affect your ability to brake and how quickly you brake. Okay, so what natural laws affect steering? Well, excuse me. Directional control, a vehicle's ability to hold a straight line or to continue in a particular direction. So your directional control is, in your steering, is how well you're able to maintain a straight line. Your steering on a curve, inertia keeps a vehicle going in a straight line, right? So you have to be able to change the direction of the steering wheel in order to meet the needs of getting around a curve. She has in here, initial feeling is that of centrifugal force. So naturally, as she said before, is that your vehicle, if everything's aligned right in your vehicle, naturally it's going to go sort of in a straight line, maybe veer a little bit left to the right, but in order to maintain steering, especially around a curve, you have to move that steering wheel with. Okay, also with the roadway build, banked roads and curves keeps water from building up on straight roadways. So if you notice, many roads, oftentimes at least one side of it, there's that little bit of, I don't know, what helps the water get off the roads. I don't know, roadway build. Just remember that how roads are built and how they're curved are going to affect your ability also while you're driving. So last one was banked roads and curves. Let's see, crowned roads that are higher in the center and drop off to the edges. So she's giving you a little picture. So there's drop off on each side. That allows the water to run off, eliminating hydroplaning. If you remember, hydroplaning is when you hit a certain amount of water and you lose control of your vehicle because the water is taking over. So crowned roads are those that have those, I guess, the drop-off edges on either side. So let's go back to that one. Banked roads or curves. The water is building up on a straight road. I'm not sure I totally understand that, but she's got a picture in here for you to take a look at. All right, lesson review. So there are 4 questions that are supposed to help you to get ready for this quiz on Wednesday. How do speed, traction, and gravity affect braking distance? Well, faster you're going, less traction, less control given the center of gravity of your vehicle is obviously going to make it harder and longer braking distance for you. Describe how steering is affected by traction and inertia. Well, that goes back up to tier 2. Conditions, steering, I was on the right one. Okay. It could affect your directional control or the steering on a curve. So both of those things, traction and inertia, can affect, you know, your ability to turn the vehicle when you need to. Let's see, what role do friction and centrifugal force play in steering around a curve? Well, that's that naturally your car is moving in a straight line. To keep friction in the road, you have to turn with the curve. And how does gravity affect on a banked or crowned road? Well, I'm not sure how I can answer that one, but looks like the water runoff, the water keeps it, keeps you from losing gravity or center of gravity of your vehicle. I don't know why she's got all these in here. Okay, well, that's the best answer I have for that one. Anyway, I hope that I helped a little bit with chapter 12 and walking you through it. I hope that it works out for you on Wednesday for your quiz. If you have questions on the quiz, definitely get in touch with me or have your dad get in touch with me, okay? All right.